In the previous class, we have seen some data transfer instruction with an example, how exactly it works and what happens after executing the instruction. And there are two more data transfer instruction where it allows the code byte of data to exchange it and data to exchange from an external memory. The first one is MOVC. So MOVC is nothing but moving a code byte to accumulator. The syntax how we need to use this MOVC instruction is MOVC A comma at A plus register. For example, you can see the instruction MOVC A comma at A plus DPTR. Now I will show one example. Move A comma hash 20H. Okay. Move DPTR comma hash 1111H. Okay. Next, I am going to use the data move A comma hash 20H, move DPTR comma hash 1111H. Now I am going to use the instruction move C. Move C, 1 minute. Now I am going to use this particular instruction move C, that is moving a code byte to accumulator. Move C A comma at A plus DPTR. Like this I am giving means how it executes, we'll see. Before that I will show the data available in the memory. 111120 means 1130. So now consider I am having 1129, 1130, 1138. Like this I am having the memory. So it is 30, 1129, 1130, 1138. After 30 it is 3A. Okay. Now you consider the data available in this memory. It is the memory, whatever I have shown in this particular column, it is the memory. Now the data available in 1129 is 1A. The data available in 11230 is 1F. The data available in 113A is 01. Like this you are having, you consider. So first when your assembler execute the first instruction, after executing the first instruction, the content of accumulator is going to be 20H. So after executing this particular instruction, the accumulator content will be 20H. After executing your second instruction, the DPTR content is going to be 1111. Okay. Now if I wanted to move a code byte of data, you consider I wanted to move a code byte of data. For that, A plus DPTR. What is the content of your accumulator? What is the content of the accumulator? You have 20. So this 20 plus what is the content of your data pointer? 1111. So these two things will be added. So when you add, you will get 1131. So when you add, you will get 1 plus 0 is 1, 2 plus 1 is 3, again 1131. So inside this 1131, what data is available, that will be moved on to the accumulator. So inside this 1131, what data will be available? So 30. So you consider this is your 31. You consider this is your 31. So it is your 31. So in this 31, what data is available? It is 01. Now the content of accumulator is going to be 01. Clear? One more example I will tell. Okay. So one more example is, you consider now MOV. One more example I will tell. Consider one example, MOV A comma hash 01H. Move dptr comma hash 1111h. Okay, now you are moving a code byte of data. Move c, it has to be used with accumulator comma at accumulator comma dp accumulator plus dptr. Before that I'll tell what data is available in the memory. So in the memory you consider, when you add 11, so you consider like 11111111121114. Okay, like this it goes on. So whatever I have shown in this particular part, it is your memory. Consider the data available in 1111 is 1a. The data available in this particular memory is 1f. The data available in this is going to be 1b. The data available in this is going to be 1f. Like this you have considered some more data are there. Now after executing your first instruction, the content of accumulator is going to be 1. So when your second instruction is executed by the assembler, the content of your data pointer is going to be 1111. So when you execute the third instruction, that is MOVC A comma at A plus dptr. So A plus dptr, what is the content of accumulator? Content of accumulator is 01. And what is available in the dptr? It is 1111. So 1111, when you add it, you will get 1111. Okay, so after adding, the value of A plus dptr is going to be 1111. So add 01, so 1 plus 1112. So after adding you are getting 1112. Inside this 1112, now it refers after at whatever number you are getting, that refers to the address. After hash, if any number is there, that represents the data. After at symbol, if you have any number, that represents the address. So inside this particular address, that is 1112, inside this address, what is the data available? 1f. That will be moved on to the accumulator. Now the content of accumulator after executing this is going to be 1f. Okay, this is how your instruction MOVC works. Clear? Now coming back to the next instruction, all these things we have explained over here. Next is your MOVx. MOVx is nothing but moving a data to or from your external memory, that is external RAM. If you wanted to move the data apart from the internal memory, external memory, if you want to share the data, that time you have to use this particular instruction. Okay, so here you can move C has to be used along with accumulator and data pointer. Apart from that, you cannot use anything else in case of move C, that is moving a code of memory into the accumulator. Whereas MOVx can be used with all these combinations. So you can see the combination of here MOVx comma MOVx. MOVx is nothing but moving a data to or from your external memory at data pointer accumulator. So for example, first one for first example I'll show. I'll tell with an example. You consider MOV, okay, moving a dptr comma hash 1111. Okay, I have written MOV dptr comma hash. So that address what we have used over here, it is a immediate addressing mode. Next you consider you have a memory. So memory in the sense here 111111121113. So like this you have memories. So inside this memory, it is your whatever I have represented over here, it is your memory. So inside this I am having 52. You consider this is the data and this is your address. For example, I am telling. Now whatever for this dptr after hash symbol, so it is going to be your data. This particular data has been loaded onto your data pointer. Now I am going to move my data to the external memory, that is MOVx at. So at dptr, when I started to use at dptr, What is the value available in the DPTR? 1111. Now at 1111 means that 1111 is going to be your address, comma, accumulator. So whatever content you have in this accumulator, you consider in accumulator you have some data 1A. Now in before execution of this particular instruction, the data available in 1111 is 52H. Okay. After executing this instruction, whatever content you have in this accumulator, that will be moved as a content towards here. Now present content of 1111. The content of 1111 is going to be 1A. Okay, this is how your external data transfer works. So these are all some of the instructions that represents your external data transfer, that is to or from the memory. So all these examples refers to as a external data transfer, that is to or from your external memory. So in the next class we will see the next instruction, that is dealing with your stack pointer. Thank you students.